This is a problem of hypothesis tests. The following data in kilograms, we were selected randomly from a normally distributed population of values represent measurement of a machine part that is supposed to weigh on average 8.3 kilograms. And these are the data. So they don't give you a summary. Actually, they give you the data. Use this data, an alpha equals 0.01, to test the hypothesis that the parts average is more than 8.3. So this will be the alternative hypothesis because they don't have an equal sign here. They say the parts average is more than 8.3. Okay, so I noticed that I need to make a hypothesis test. They tell me here, test the hypothesis. Okay, so go here, stat, because I don't know the population standard deviation, I'm going to use t-stats again, okay? If I don't know the population standard deviation, I use the t-stat. And here I don't know, they don't tell me the population standard deviation. So I'm going to get here one sample, but now instead of getting summary, I will be telling you with data, okay? This will be the difference now. If I give you all the data, so you need to tell with data. Usually this problem that have the data have a link for StatCrunch. Okay, these are the problems that have the link for StatCrunch. You open this link and after that the StatCrunch will be open during the test. Okay, with data, choose one sample. You see here, these values are in variable one. These are the only variable that we have so far. Sometimes appears here home or salary or whatever. Yeah, and there are several variables. But here there is only one variable. It's called var1. Okay, so you get here stat, t-stat, one sample with data. What is the data in variable one? So you choose the variable. It will appear in here immediately. Here is optional. Don't worry about this. You need to tell that this is a hypothesis test what you are doing, okay? By default, it will have an equal sign here, but this is wrong. Yeah? Sometimes it's not equal. Sometimes it's more or equal, or sometimes it's less or equal. But there will be always an equals. For that reason, this equal appears here. Because the alternative is more than 80.3, just change this symbol more than. There are three options. This is not equal, depending on the problem. This is less than, this is more than. So I'm going to choose more than. There is no equal here, yeah? So it will be more than, and the number is 8.3. 8.3. You need to choose the significant, yeah? Show critical value, choose this, and the significant is 0.01, 0.01. Here there are several plugs that you can make with the data. The one that could be important for hypothesis testing will be this p-value, if you want to see a plot. And then press compute. The answer appears in one table. Here is the variable. Here is the sample mean. So they compute the sample. So, and the sample mean is 8.395. This is the standard error. So it will be S divided by root of n. This number at the bottom, S divided by root of n. The degree of freedom is 19 because we have 20 data. The t statistic is 2.4540. And the p-value is 0.012. The p-value for me is what helped me immediately to make the decision. If I notice that the p-value is more than this number, than alpha, I don't going to reject the null hypothesis. There is not enough evidence to reject the null hypothesis. So if the p-value is bigger than alpha, immediately you can immediately say, we fail to reject, yeah? Or there is not enough evidence to reject the null hypothesis. So do not reject the null hypothesis, okay? That will be our decision. At this level of significance, we cannot reject the null hypothesis. That's it.